goes into checking data items to make sure that they are valid and reasonable. Remember, we've got a thing called human error in data capture. Can anyone remember what actually GIGO stands for? Yes, garbage in and garbage out. So if the user, human, inserts the incorrect data, of course we're going to have the incorrect analysis of that data and the incorrect outcome of that data. Not so? So, procedural programming handled errors in various ways that were effective, but these techniques had some drawbacks to them. And that is why object-oriented programming created a new model called exception handling. Remember, you've got to remember that your programs should expect that there are going to be some errors, typos, or unexpected data. And they are going to occur in your programs. And to be a good programmer, you need to plan ways to actually handle these errors. So let's discuss the drawbacks to the traditional error handling techniques of procedural programming. Well, the most often used error handling outcome in traditional programming was to terminate the program, meaning exit the program or exit the method. Oh, it was so unforgiving. And it's completely unstructured. You'll see why now when you discuss an example of a procedural. Another one that we can do is forcing the user to re-enter data or limiting the number of chances the user gets to enter the correct data. Re-enter sounds good. Limiting selection. Yeah, that sounds pretty good. So let's discuss the first one. First one here is a procedure called determine premium. So what we're going to do is we're going to determine the premium, do the calculations of auto and health premiums only if we first do a little check. So the check will tell me whether the procedure type is A, auto, and health. All right, we're checking whether this data was captured correctly by using a if selection and using the not symbols. If this section here was true and this was true and they were both using the conditional and the whole thing true, then we're going to return to where? The method call. And here we're going to return again to the method call when we end the method. This is not structured. You can't have two return statements. Remember, you've got to have one entry and one exit. That means structured. Okay, so you say to me, the method should be fine. But if the method was part of a business program or a game, you're going to get one really annoyed user. Or worse, what if the method was a method monitors the hospital's patient's vital signs? Or navigates a plane. Oh my word, the program will continue with an invalid value continuously, because remember we've just exit here, and might stop working. So, we're going to have a plane crash. Okay, so let's discuss the second traditional error handling technique of using loops and selections. Yes, it's a more elegant solution, looping until the data item becomes valid, but there is some shortcomings. The method is not very reusable. And when I mean by reusable, remember one principle of object-oriented programming is reusability. Next would be the method is not very flexible. So your program will carry on and on. There's no restriction to how many times this user gets a chance, right? You need a limit. So more flexible method would be to actually calculate the premium amount without decision about data errors, right? Or detect error and notify a calling person or program that an error has occurred. That will probably be the most flexible. Only works with interactive programs. So what is going to happen when data being retrieved from a disk file? You are trying to retrieve data from the CD, but are you going to reprompt a file that does not exist? If stored data is invalid, it remains invalid. So let's discuss this method that handles error using a loop. You can see here's my while loop. All we're doing here is we're prompting the user for A or H, And if it is incorrectly captured, then we're allowing them to re-enter and keep entering until they get it right. But you can see that there's nothing here telling them what they're doing wrong. Then there's nothing here showing them what they're actually typing in. What are they typing in? Maybe they don't know that their keyboard is not on caps, or it is on caps, so they keep typing in the small a or the small h. Object-oriented exception handling model. A specific group of techniques for handling errors in object-oriented programs. And we're going to discuss every single one of them. We've got exceptions. Exceptions is the generic name used for errors in object-oriented programming languages, because errors are not usually occurrences, they are exceptions to the rule. All right. So I'm sure you've come across a lot of exceptions in Java. So exceptions in Java would be runtime exceptions, input-output exceptions, file not found exceptions, index out of bounds exception. Does these all sound familiar to you? Arithmetic exception, number format exception in Java. I'm sure you've seen this when you've compiled your programs and the error message comes up at the bottom. So exceptions is the generic name used for errors in object-oriented programming. Try some code that might throw an exception. Have you ever done that? So you try a bit of code and you say it might throw an exception, might throw an input-output exception, but we try the code first and see if it works. That would be another way of object-oriented exception handling model. If an exception is thrown, it is passed to a block of code that can catch the exception. So this is another one which we can use. Another model is a catch the exception when it is thrown. So as you'll see just now is that you're going to have a parameter for a catch, which is going to receive it in a similar way to how a parameter received by a method that you've already done. So we learned that through parameter passing, we can pass any data item, whether it can be a string or a programmer-created object, like in 10.7. All right, so let's discuss these models a little bit more. First one, throw statement. What does it do? It sends an exception object out of the current code block or method so it can be handled elsewhere. All right? So it's got a built-in class exception or a derived one, like in Java. Then you got the try block. This is used for a segment of code that might go wrong. So it's a block of code that you attempt to execute while acknowledging that an exception might actually occur. The key word is try, followed by a number of statements. And if the statement in the block causes an exception, then the remaining statements in the try block do not actually execute. And the try block is abandoned. And where does it go? For pseudocode, the end a try block with sentinels such as end try. So you will have try, you'll try some code, and then you'll end the try. And then you're going to catch whatever we have that goes wrong. All right, so let's discuss throw statements. Here in figure 1124, a method that creates and throws an exception object. So what we're doing is we're using the selection statement that we used earlier on, and we are going to say that we're going to use a object mistake of the exception class, and then we're going to use the keyword throw mistake. So if it throws a mistake, so in other words, we're not going to have two return statements now. We are just throwing what that object is, what that mistake would be. Now, with the try block, you are going to get a catch block. And this catch block is a segment of code that can handle an exception. So remember, we try some code and then we catch the exception. The keyword is catch here, followed by a parentheses that will contain the exception type. And then there's going to be statements that take the action you want to use to handle the error condition. The end catch statement indicates the end of the catch block in the pseudocode. So like we open a try block with try, we have to end a try. And how we open a catch, we have to end a catch as well. You must always code at least one catch block immediately after a try block. So we have a try, end try, catch, end catch. And here is in the parentheses, we have our exception mistake. So we're using the exception class here, and we're creating ourselves an object instantiated from the exception class. And what we're going to do is we're going to output a mistake has occurred, which is quite nice. And then we're going to end catch. Note that this is an application program. Do you see that? It's got the start and stop. So this is what you would do in the application program. Determine premium would probably be at the bottom here somewhere. So this would be at the bottom here without having the exceptions, mistakes, throw exceptions. So it'll be quite handy. So these are the two different methods that you can do. The catch might look like a method, but it is not, as it has no return type. Do you see? There is no return type here. Therefore, it cannot be called directly. That is why we have to have a try with a catch in order for this to work. So these two go hand in hand together. So the general principle in exception handling is the method that uses the data should be able to detect errors, but not be required to actually handle them. Handling should be left to the application that uses the object. Like in our try block here, it's with the application. The sunny day case. Oh, I love this. The sunny day case is basically when there is no exceptions and nothing goes wrong with the program. I love the sunny day case.